there! Rahul went to a studio to get some passport and stamp-sized photographs. When he looked at them, he realized that the stamp-sized photograph was of the same shape as the passport-sized photograph but smaller. And when he looked at two passport-sized photographs, he noticed how they were of the same shape and size. He could superimpose one over the other like this. Just like these photographs, even geometrical figures can be of the same shape and size. We call such figures congruent figures. To understand this better, let's study congruent triangles. If two triangles are congruent, then their corresponding sides and angles are equal. For instance, if we consider the congruent triangles ABC and PQR, then AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Further, angle B is equal to angle Q, angle C is equal to angle R, and angle A is equal to angle P. Whoa, that's a mouthful. Does that mean that to determine if two given triangles are congruent or not, we have to compare all the 6 elements of the two triangles? Not really. We need only 3 elements to be equal. The question is, which 3 elements? Let's consider two triangles ABC and PQR such that AB is equal to PQ, AC is equal to PR, and angle A is equal to angle P. So we see that two sides and their included angle in one triangle are equal to the corresponding two sides and their included angle in the other triangle. Do you think these triangles are congruent? Let's move PQR and see if it superimposes over ABC. Look! Triangle PQR superimposes exactly over triangle ABC. This means the two triangles are congruent. And since the two triangles are congruent, BC is equal to QR and angles B and C are equal to angles Q and R respectively, as they are corresponding parts of congruent triangles. This brings us to an important conclusion, that is, if two sides and their included angle in one triangle are equal to the two sides and their included angle in another triangle, then the two triangles are congruent. This rule is called the SAS criterion for congruence. Note that the A lies between the two S's to indicate that the angle must lie between the two sides. But is this always true? Let's look at another pair of triangles. As you can see, two sides and their included angle in one triangle are equal to two sides and their included angle in the other. Let's try superimposing them. Do they overlap? Yes, they do, which is why we can safely conclude that this criterion holds good always. So we can say that if two triangles satisfy the SAS criterion, they are congruent. Interesting, isn't it? Well, that's all for today. Besides, even Rahul's photographs are ready and he's on his way back home. Perhaps you should go and practice some congruency yourself now. See you next time then.